Good morning, and thanks for joining me here today. I'm Joe Reinhardt, a graduate student in the Appalachian State University Appropriate Technologies program, and we're here on this cold day at our biodiesel research and testing facility to talk about a much warmer topic, recirculating aquaculture systems. You can think of recirculating aquaculture systems as a very large aquarium, raising fish for food instead of for pets, but using a limited amount of water to it. Commercially scaled systems can raise tens of thousands of pounds of fish per year, but create a lot of waste doing it. This system will raise about 400 pounds of fish per year and cost about $1,000 as compared to a commercially scaled system of this size, which would cost about $2,500. It'll also make best use of the waste. This size of a system would be perfect for a family looking for some extra income and a fun hobby, or for a couple of families that were looking for some inexpensive food in case you were, say, facing the worst economic downturn since the Great Depression. We'll come back and talk about the specific components of this system in a few minutes, but first let's go inside and talk about a few of the key concepts in making a recirculating aquaculture system. Welcome to our greenhouse where we house our living machine, which we use to treat wastewater from our biodiesel facility in much the same way as a recirculating aquaculture system treats the wastewater from fish. Water enters the facility through these tanks here and is treated in these tanks and these tanks until all the waste products in it have been turned into nutrients, which we use to grow these plants here, which then renders the water clean, and so we can use it again in our biodiesel facility. Our recirculating aquaculture system works in much the same way, turning fish waste into nutrients, which are then removed by plants, and then the water can be recycled back into the fish tanks. Of course, the first thing fish need to grow is food. If you're growing fish seriously, you'll probably be using a lot of this, commercial fish food, which provides a balanced diet for fish, and especially all the micronutrients that fish need. Of course, as every child knows, a fish will eat everything, even toads, which is great because it allows farmers to recycle abundant waste streams into fish food, both cutting costs and cutting waste. Common sources of fish food are leftover bread goods and also leafy greens if you're growing the right kind of fish. Around here, we use a lot of this stuff, which is canola meal, which we get from pressing canola seed into canola oil. The second key to a healthy system is making sure that fish have enough oxygen to grow. Just like humans, fish breathe oxygen, but they breathe theirs out of the water in dissolved oxygen instead of out of the air. And because fish are constantly taking oxygen out of the water, we have to make sure we're constantly putting it back in. In our system, that's done in three ways. Algae, during the day, photosynthesize and take carbon dioxide out of the water, turning it into carbon for them to grow and oxygen for fish to breathe. Secondly, we add oxygen to water by passing water through the air. In our system, that's done by taking water from the pond and pumping it all the way over to these tanks, which forces water back through the system and over to here, where water flows through the air, adding oxygen back into the water. Lastly, we use an air pump like this one and compress air and pass it through the water in air stones like this one. Regardless of how you add oxygen back into their system, you'll need to maintain a minimum level of 5 parts per million, or milligrams per liter, in order to keep healthy fish. In order to test that, you use a dissolved oxygen test kit, like this one, in order to make sure you don't fall below the minimum level. The other big need for healthy fish is clean water, which is the biggest problem for recirculating aquaculture systems because they don't just dispose of their waste downstream, but mistreat it themselves. This waste consists of two forms. Particulate matter made up of dead algae, leftover food, and fish feces is actually relatively easy to remove, and we'll look at how we do that when we look at our system outside. The second form is chemical waste, mostly composed of fish urine, which contains ammonia, NH3, which is toxic to fish. But another form of nitrogen, NO3-, is both harmless to fish and a great fertilizer for plants. So the trick is then to get from ammonia to nitrate. In nature, this process happens via nitrifying bacteria that exist on rocks and banks in rivers and streams. These bacteria take ammonia from fish, add oxygen, and turn it into nutrients for plants. Aquaculture systems do the same thing via biofilters, but in a concentrated environment. These filters take nitrifying bacteria from the environment and give them a place to stick by filling a barrel with gravel and oxygen via an air pump, just like in this picture. This would be a great time to go look at the construction of one, so let's take a look at our system outside. Here we are back at our system, so let's take a look at how these components work together to treat the waste in the system. The process starts here, in the two large water tanks. Here is where our fish are and where we add food and where the fish create the waste. The water moves into these tanks through this pipe here, which is fed from a pump in the pond at the end of the system. This process adds air back into the system as well, which is also added in from this large air stone in the tank in front of me. Water then moves from this pipe here over to the clarifier, where we settle out the solids from the system. We need to clean this tank out about once a week in order to keep the solid levels low. These solids are essentially manure and are great for your compost. The black plastic netting in the tank helps the solids settle out and also keeps them from being recirculated. Next, the water flows into this tank here, our biofilter. When finished, this biofilter will be filled with gravel, but for now you can see that the water flows in through the bottom pipe there and filters up through the gravel, along with oxygen from the air stones, to go through the nitrifying bacteria and to emerge with much lower levels of ammonia and much higher levels of nitrates. Many systems would just let those nitrates build up, but in this system we'll actually be using those nitrates to grow plants in this tank here and in this pond here. Commonly people grow this plant here, water hyacinth, which can be great when put into compost or used in a methane digester. Much more useful to us is a plant called duckweed, which is a rapidly growing plant that grows on the surface of water and can be fed back to tilapia in order to create more food for fish. Well, that about wraps it up for us here today. If you think you might be interested in pursuing sustainable aquaculture, stay tuned for a few resources to get you started. Thanks again.